Hi, today's lecture is about the assessment and design of the physical environment in terms of the air quality and ventilation. While performing some of the production processes or activities, some dust or vapors or smoke may be emitted. These emitted substances that are created while performing these activities or processes may contaminate the work environment. In some cases, these contaminants become toxic, flammable, or explosive. In this case, the quality of the air being inhaled may deteriorate, especially when there's excessive humidity or heat. Another issue that is disregarded as well in any facility is the presence of furniture or carpets or some materials that are commonly used and commonly found in any facility. Now, these objects slowly emit gases and chemicals that can build up over time in the air, and sometimes these gases or chemicals become toxic. Now, to improve the quality of the air and to reduce the effect of the harmful airborne contaminants, some approaches can be done, including good housekeeping, the use of less toxic material, for example, exchanging the carpets with epoxy floors, isolating the furniture by wrapping it with plastic covers, for example, enclosures, close things that or machines that emit some fumes, introduce the ventilation systems, and using personal protective equipment. Ventilation is the most important strategy among all these mentioned methods. Now, the new trend in facilities is to provide natural ventilation by roof air vents or doors and windows and other openings, but this has been a trend because the new and modern buildings are tightly sealed, to improve the energy efficiency. Now, the main objective of the ventilation system is to keep the level of contaminants in the air within the acceptable levels. And the good ventilation system will remove these contaminants as quickly as they are produced. As they are produced, it should be eliminated by the ventilation system, or else these contaminants will build up over time and the level of it will become an unacceptable one. If you want to classify the ventilation systems, we have two broad categories. We have the general or dilution ventilation system, where fresh, clean air is brought from outside the facility to dilute the level of contaminants in the air. And the other category is the local exhaust ventilation system, where air contaminants are being sucked and removed immediately as it's being produced, and this will prevent them from entering the work environment. For the general or dilution ventilation, imagine that you have a fan that is blowing air, the outside air, the fresh air, into the room. What happens is that the newly freshly introduced air will mix with the contaminated air, and it will dilute it and lessen its effect, and the level of these contaminants will become or reach an acceptable level. And this will prevent this contaminated air from spreading through the doors and other openings. So it will be diluted before being spread. And on the other side, if we have a fan that is blowing the contaminated air outside the facility, in this case, the fresh air will be administered through vents or other openings, while the diluted air will be going out of the window. As for the local exhaust ventilation, this system consists of several hoods. The hood is located where the contamination or the contaminant material is being produced. It's similar to the one that we see in the kitchen above the oven to suck all the fumes and smells. This is the industrial one. It's found to get these fumes that's emitted by the industrial processes. Now, these hoods are connected by ducts leading to an exhaust vent. The effectiveness of this exhaust ventilation depends greatly on how close this hood to the source of contamination. If it's very far away, as the distance increases from the source of the contamination, then these contaminants can be spread out into the environment of the workplace. Now, there is an issue related to both types of the ventilation system, is that they sometimes reintroduce the filtered air or the diluted air, reintroduce it to the work environment after filtering it. So in this case, the air will be recirculated into the environment after being filtered, instead of introducing a purely fresh air from outside. Now, why do they do that? They do that to reduce the cost of energy, because if they recirculate the already cooled air back again into the work environment, they will be reducing the cost of getting fresh air. This fresh air from outside might be very hot. They will have to cool it down first by air conditions, then introduce it to the work environment. So they find it cheaper to recirculate the diluted or the filtered air. Now, this is acceptable, this is okay, as long as the filters are properly maintained, because if we have a problem with the filters, then the contaminants will go back again to the work environment. Now, regarding temperature and humidity, no matter what's the work environment that people work at, people sometimes work at environments with high temperature and humidity. Others work with temperatures below the freezing point. Now, the beautiful thing is that the human body can adapt no matter what are the conditions. The body will regulate in order to maintain the body temperature ranging from between 36 to 37 degrees Celsius. This process is known as thermal regulation. Our bodies generate heat usually by metabolism. But when this heat starts to flow out of the body, then in this case, people will start feeling cold, and the body will make several responses to reduce this flow of heat outside of the body. Now, these responses might be some shivering in order to increase the heat generated by metabolism, and reduced flow of blood to the extremities and skin in order to reduce the rate at which the heat is transferred out of the body. On the other hand, when the flow of the heat out of the body is less than the heat generated by metabolism, in this case, people will start feeling hot. likewise, the body will make several responses to increase the flow of heat out of the body. Now, these responses may include tiredness, because when people feel tired, they will be less active, and consequently, this will reduce the heat generated by metabolism, and this will increase the flow of blood to the extremities and skin, thus increasing the rate at which heat is transferred out of the body. If these physiological responses of the body are not adequate enough to maintain a balance between the heat coming in and the heat coming out, then our system will no longer be in equilibrium, and thus there will be a change in the amount of the heat stored in our bodies, and these changes can result in severe consequences. Thus, we will be uncomfortable or stressed out. Now, how is the heat transferred? Usually, people produce heat and receive heat from the air, and the heat generated by metabolism depends on how active people are. Usually people will produce about 60 kilocalories per hour when being at rest, when they are not being active, to about 4,000 kilocalories per hour when they are doing some activities that require heavy exertion of force. The human body can gain or lose thermal energy from the environment through convection, conduction, radiation, and evaporation. Now, conduction is the transfer of thermal energy through direct contact, such as when you put a piece of ice on your hand and it starts melting down. So there's a type of thermal energy exchange, and it happened through direct contact. Convection is the transfer of thermal energy through the movement of a liquid or gas. For example, when the water temperature is lower than the body's temperature, the body loses heat by warming the water closest to the skin, which moves away to be replaced by cooler water. So with conduction and convection, heat enters the body when hot air molecules are cooled by contact with the skin, and leaves the body when cool air molecules are warmed by the skin. This cooling and heating causes convective air currents, which increase the rate of heat transfer. You have to understand that the thermal exchange rate increases when more skin is exposed to the air and with lower insulative clothing. The rate of heat loss or gain through conduction or convection depends on the exposed area of the person's skin and air temperature difference, the difference between the skin and the air temperature, difference between the temperature of the skin and the temperature of the air, insulative values of the clothing covering the non-exposed skin, the velocity of the air surrounding the body. The human body as well can gain or lose thermal energy from the environment through radiation. Now, examples of radiation can be the sun, lamps, or for example, if you're sitting near to a fire on a cold night. Now, the side of you facing the fire is warmed and the side away from the fire will be cold. This is the feeling of the radiation. This is similar to the heat from the sun warming your face. Now the last type is evaporation, but with evaporation we only lose heat by the body. We do not gain heat by evaporation. The heat loss by evaporation depends on the wetted skin area, the air velocity, and the saturation deficit of the air. Now, what's the meaning of saturation deficit? It is the difference between the existing humidity and saturated air. For example, when the body sweats, it loses heat. This heat is transferred to the air. Now, if this air is cool and cold, then this heat can be transferred to the air. But imagine that the air is already very humid. Then how can the humidity or the heat produced from our bodies be absorbed by the air if the air is already saturated? So the difference between the existing humidity and the heat that is transferred out of our body and the degree of saturation of air with humidity, this is the saturation deficit, and as it increases, the greater heat loss occurs through evaporation. Now, in this section, we'll talk about control strategies for hot or cold environment. We basically have two types of controls. We have the engineering controls and we have the administrative controls. Now for the engineering controls, the primary controls are used include adequate heating, ventilation, and air conditioning in order to modify hot or cold environments. Heating and air conditioning systems modify both the air temperature and the humidity, and this is our first choice to improve the atmosphere inside any work environment. Heating and cooling costs is a very important consideration because we have costs included in order to perform the heating or the cooling. For example, if we have the warehouse of a facility that requires cooling, since we are storing, let's say, items that can be spoiled easily. So in this case, determining the energy required to keep this facility cool is very important, and we have to take into consideration if it's economically feasible or not. Another engineering control is to increase the airflow around the people in order to increase the evaporation. So this is effective only at lower humidity levels and depends on how rapid the air is moving around a person. Now, the location of fans is important because you have to understand that the velocity of the air provided by the fan will drop as it hits a person. So the air velocity will drop with distance as it crosses and hits several people. So this has to be understood. Other engineering controls may include placing heat producing equipment in a location far away from where most of the people work or do not go, provide an air-conditioned space, the space at which most of the people are working, the work environment, to include metallic shielding to reduce exposure to hot radiating source, or provide some tents, windbreaks, or shelters for cold situations. Now, the administrative controls, remember that the administrative controls are workplace policies, procedure, practices done by the organization to minimize the exposure of workers to risks. So management can provide equipment that help people perform some of the heavier tasks such as lifting. So instead of people doing the lifting, and in this way their metabolism will increase, instead of letting people do the heavy tasks, the management would provide equipment that would do that instead. Or management would increase the number of personnel to reduce the amount of work done by each worker. Also, employees should get water and salt in order to stay hydrated. You know, when we sweat, we lose the electrolytes such as the sodium, the chloride, and potassium, in addition to the water that's being lost. So management should try always to provide water to the workers. A worker should get a cup of water at least every half an hour to stay hydrated, especially in hot working environments. Now, most people are able to restore the electrolytes through normal meals and snack. This is how we can restore the salts that we lost through sweating, not necessarily that we should take large amounts of salts. So management should also provide workers with breaks so that they can get some rest and restore what they have lost through sweating by having some decent meals in a place where it's shed, not in the direct sun, and so on. Protective clothing as well can be a good solution for cold environments, and also play a useful role in hot environments as well. Some situations require people to work outside in extremely cold weather conditions. Sometimes people have to work in refrigerated areas, so the protective clothing is necessary. There are some clothing that provide cooling capabilities. For example, there are some cooling vests with pockets where we can insert cold packs, and this is very useful to keep workers cooler for longer periods of time. Other vests also contain sealed liquids that absorb heat, and thus keeping the workers also cool. There are also some protective clothing, for example, those developed for welders. The clothing would be flame resistant, so that to protect the welder from sparks and flames. Also, there are some reflecting clothing providing protection against radiant heat. There are also the high visibility vests used by people who work outside, especially at night those who direct the traffic. You see that they wear some vests with fluorescent colors, with special reflective features so that people can pay attention to them. Also, there are some vests that could be worn over the coats, so they would be loose fitting, with a loose fitting design. Makes it comfortable to be worn over the coats so that to provide more heat for people wearing them. Also, these loose open fits allow the air movement, making it more comfortable when worn outside on a hot day. There is one issue related to gloves. Now, sometimes you have to wear gloves for protection, but this might interfere with the finger movements. So, a clever solution was to provide gloves that include a finger flap. So, this flap can be removed, allowing the fingers to be uncovered so that the worker can do a certain activity that requires um, moving things with his own fingers. Now, the last part of this lecture is about assessing thermal conditions and comfort. There are 7 factors that impact heat exchange between human body and the environment, which are air temperature, air humidity, air movement velocity, radiative heating, exertion level, or the force exerted by the person, clothing, and the duration of exposure to heat or cold temperature. And since we have so many factors that impact heat transfer, it is difficult to predict how comfortable people will be in different thermal environments. So the starting point in the assessment of thermal conditions is to measure air temperature and humidity. Also measure radiative heating effects and air movement velocity. Now, there has been so many studies that has been done to study the effect of the thermal environment on human performance at the work environment. These studies didn't find strong effects unless the atmospheric conditions were quite extreme. Now, people generally can cope well with different environmental conditions, but problems in performance are start to be found when temperatures are really low. So people begin to show severe signs of mental confusion, and they have people may show difficulty with handling the tools and working with these tools, even striking a match when people's hands are cold is very difficult. So the problems usually are found when the temperatures are really low. Otherwise, people can cope well with normal environmental conditions. That's it for today. Thank you for listening.